Hi, everybody. Mr. Rubo here. Today we continue with topic 2.13, exponential and log inverses and inequalities. This video is going to focus on when we have multiple logs. So when working with more than one log, we can use our log properties to simplify expressions before solving the equation or inequality. For equations and inequalities involving multiple logs, we generally simplify to one of these forms. So either we're going to simplify to the form where we have one log of x equals b. So there's only one log on one side. These ones we solve by converting to exponentials. Okay. The other option, and by option I mean the other method, is when you would have two logs, but they're on opposite sides. So, and just the two logs. So, there it is. In this case, in form 2, the logs, because they're same base and everything, they just cancel out and you're just left with the inside equals the inside. So x equals y. Okay. Kind of two very important notes. In either case, you have to check for extraneous solutions. Because logs have restricted domains, you can have extraneous solutions that you get but don't work because they're not in the domain. Okay. And then number 2, log x plus log y equals log z does not imply x plus y equals z. You have to use log properties. You can't just cancel out the logs when there's more than one log on one side and only one log on the other. You can only cancel them out if it's one log equals another log. All right, so let's do a couple examples here, and then we'll call it a day. So here, log base 10 of 3 plus log base 10 of x plus 4 equals log base 10 of 5x minus 2. So we have two logs over here. So we got to use our log properties to make it one log. Well, because they're added, that would mean I multiply. Okay. And now I have that form 2. My stylus doesn't want to work. There we go. Where it's a log equals a log. So this is where I can cancel them out. Okay. If you cancel them out too early, you're going to get a very different answer and an incorrect answer. So now I'm going to distribute out this 3. And this should hopefully be something you can solve, as we've been solving these things since pre-algebra. Right, so I'm going to subtract, so I get 2x. I'm going to add, so I get 14. So x would equal 7. But you do want to check to make sure that you will get positive numbers inside of your log, because again, the domain is from 0 to infinity. So you just have to see, do you get positive numbers? So 7 plus 4, is that greater than 0? Yes. Is 5 times 7 minus 2 greater than 0? Yes, that's 35 minus 2. So that's definitely bigger than 0. Okay, so that means x equals 7 is the answer here. All right, so then we look at b. B now has a natural log. Well, guess what? It's still a log, so you just follow your log properties. Subtraction means division. So x plus 1 over 3x minus 5 equals ln of 7. And guess what? Even though it's an ln, it just goes away because it's a log on both sides. So you get this. And then to solve this guy, you would multiply both sides by the denominator. Okay, so we get x plus 1 equals, and I'm going to distribute that out. So 21x minus 35. I'm going to get 36 equals 20x. Oh, excuse me. Sorry about that. And then solve that. So x would equal 36 over 20, which simplifies to 9 over 5. Okay. And again, we got to double check. 9/5 plus 1, is that greater than 0? Yes, both are positive. 3 times 9/5 minus 5, is that greater than 0? That might be something you gotta worry about, but 9/5 is just about 2. So it does end up that you do get something a little bit bigger. What it would be 27 fifths, where this is 25 fifths. So it is bigger than 0. So you're good. And there's your answer. So you do have to check it with all the logs, okay? Because they all have to be greater than 0. If they're not, then it's an extraneous solution. All right, that's it for today. So thanks for watching and have a good day.